Hey guys, good afternoon. This is Professor David J. De Los Reyes. It's January 30, 2023. It's good afternoon here in Los Angeles. Okay, my topic for this afternoon will be a continuation of the advanced mathematics topic, and I think this is now lesson number 8. We are now on lesson number 8. The contents of lesson number 8 will still be a non-homogeneous differential equation in which the right hand side is not equal to 0, and for this afternoon the right hand side is twice cosine of x. Okay. Because I have given you already example on in which the right hand side is an exponential function, pure exponential. Another example in which the right hand side is a combination of algebraic and a sine function. I have given you an example in which the right hand side is a pure algebraic function. Okay. Another example in which the right hand side is still an exponential function, but the left hand side is different from the previous one. I have given you an example in which the right hand side is a pure sine function. Okay. So for this afternoon, okay, I will now give you an example in which the left hand side is a third order differential equation and the right hand side is a pure cosine. So this is actually the first time that I will be giving a non-homogeneous differential equation, meaning the evaluation problem, in which the right hand side is a pure cosine function. Okay, let's proceed. I will check my camera. Okay. My camera is fine. Oh, I will check it again. Oh, it's still fine. Okay. We are now on lesson number 8, advanced mathematics lesson number 8. For the meantime, we are given a third order non-homogeneous differential equation. So this will now be evaluation problem example number 7. Okay, let's proceed. The given third order differential equation which is non-homogeneous is y triple prime minus y double prime is equal to twice cosine of x. The right hand side is not equal to 0, and for the meantime it is twice cosine of x. It's another variation. So as you notice it, I'm giving examples in which the right hand side are actually different from the others. Okay, the problem is asking for the general solution. Okay, let's try to bring out the solution. As always, we will start always with the complementary solution. For the complementary solution, as always, the value of y sub c, meaning c here refers to complementary, y sub c will be k e to the mx. We needed y triple prime and y double prime. So we must have to take the derivative of this a maximum of 3 times, because we are under third order for the meantime. Y prime of c will be km e to the mx. That's the first derivative. The second derivative will be a km square e to the mx. The third derivative will be take the derivative of the second derivative. What will come out will be the third derivative, or y double prime, triple prime of c equal to km cube e to the mx. This is just pure differentiation, guys. Okay, exponential function and constant, so it will be km square and km cube e to the mx. Substituting, we will take the value of y double prime and the value of y triple prime. We put it on the original third order differential equation. So after the substitution, what will come out will be a km cube e to the mx minus km e to the mx equal to 0. The motto of the problem, also, or the principle, what we call this, the purpose of the problem now is to compute for m. So if we try to compute for m, we must have to eliminate the common terms here. or we'll just multiply all the terms by 1 over k e to the mx. This cancels, and so with this, because we got a key m e to the mx on the denominator, what comes out will be an m cube. Next one, this cancels. Second term on the left will just be simply minus m, and this should be equal to 0. And this is actually termed too as the characteristic equation. Okay? By using our knowledge on how to compute for the value of the roots of m, this is m cube in m. Actually, there is a common factor m. So what will come out will be an m square minus 1 equal to 0. M square times m is m cube. M minus times minus 1 will be minus m. Then we'll try to place, sorry for this one. This should be m square, m minus 1. Then we will place the value m square as simply the product of m minus 0 times m minus 0 times this quantity here. So I place it here. The quantity m minus 0 times the quantity m minus 0 times the quantity m minus 1, and this should be equal to 0, the characteristic equation. Then to compute for the possible roots, equate its factor of 0. m1 now will be 0 by using this. m2 now will still be 0 by using this. The third value of m sub 3. If we equate this to 0, it will go to the right, this will become plus, so m3 will be actually plus 1. Okay? Then we'll try to combine this one. It falls under case number 1. Okay? m3, it is allowed, so it will just be simply a constant of integration times a raised to the value of m3. Okay? So the complementary solution now will be a k1 plus k2x quantity, open quantity close quantity times e raised to the common value of m, which is actually 0 times x. That falls under case number 1. They are both real and equal, okay? Plus k3 e to the x. But this is 0 times x. 0 times x is actually 0, and e to the 0 is 1. So we could actually replace this by, this is multiplied by 1. So the complementary solution now will just be simply a k1. Since this is 1, 1 times k1 will be k1, k2x times 1 will still be k2x plus k3 e to the x. This is the complementary solution. As simple as that one. For the particular solution, we will try y sub p, meaning particular solution, equal to, since the right hand side contains a cosine function, and we keep repeating, differentiating this up to the third time, there come a time that there will be a sine function. So we will anticipate that the particular solution contains also a sine function. So for the meantime, we will place y particular to be equal to a cosine of x plus b sine of x. This x here corresponds to this. The first part, since this is cosine, we assume that the particular, there should be a cosine function. And we also anticipate that there should be a sine function. So it will be another constant b times sine of x. The angles here are the same, okay? So, and it emanates from this. So particular solution will be an unknown constant a cosine of x plus an unknown constant b sine of x. Okay, that's our assumed particular solution. Okay, taking the first derivative, y prime of p will be negative a sine of x plus b cosine of x. This will become negative because this is cosine. We take the derivative, it will be negative sign, so this should be negative a sine of x plus b cosine of x. The derivative of sine is plus cosine, so the sine of this is still plus. Y double prime of p will be, we'll take the derivative of the first derivative. The derivative of sine is plus cosine, so the sine of it will just be simply negative times a plus will be still a negative a cosine of x. For the second part, the derivative of cosine now will be negative sign. So a plus and a minus, this will become minus now, minus b sine of x. Taking the derivative of the second derivative, what will come out will be, the third derivative will be a sine of x minus b cosine of x. This is cosine, okay? The derivative will be negative sign. So negative, negative, this will now be plus. This is plus. Okay? For the second one, it is b. The derivative of sine is plus cosine. So it still be negative b cosine of x. That's the third derivative. Then taking the value of the third derivative and the second derivative, we place it in the original differential equation. We'll follow this. So the value a sine x plus minus b sine of x is actually the third derivative, right? It's this. Minus open quantity. I'm following this. Computed value of the second derivative. The second derivative is actually negative a cosine of x, negative b sine of x. I place the negative sign here because it's very dangerous, because this is negative, because just in case we miss this one, we are wrong already. So negative open quantity, negative a cosine of x minus b sine of x, close quantity, and this should be equal to the right hand side, twice cosine of x. Expanding this one, this should be a sine x minus b cosine x, minus minus will now be plus a cosine of x, minus minus, this will be plus b sine of x equal to twice cosine of x. So if you try to notice it, the resulting left hand side is a combination, or there are terms which contains the sine function and the cosine function. That is where we will formulate the equation on how to compute for the value of a and b. Okay, so equating coefficient of like terms, it is just like on the partial fraction, right? For all the terms that contain sine of x on the left, the first coefficient is a. It is a. The next coefficient is actually b. So this is plus b. On the right hand side, it is equal to 0. Actually, on the right hand side, there is a sine function, sine of x. Okay? But unluckily, the coefficient is actually 0. Okay? Because this is sine, this side, this is a plus b. So on the right hand side, there is a sine x, but unluckily, the coefficient is actually 0. So the right hand side will be 0. So a now will be negative b. We call this equation number 1. This is now a part of algebra. We have formulated a linear equation that contains the unknowns a and b. Okay? For cosine of x. For cosine of x. On the left hand side, the first coefficient is negative b. This is negative b. The next one is actually plus a. This is the next cosine function. This is plus a. And for the right hand side, it is the given right hand side. Twice cosine of x. Okay? Cosine of x, cosine of x, cosine of x. So this is actually negative a plus a should be equal to, the coefficient of cosine on the right is actually 2. This is 2. So this is now our equation number 2. This is now the algebra portion. We have formulated equations 1 and 2, in which the unknowns are a and b. Okay, so using the value a minus b, we put it on equation number 2. So what will come out? Negative b plus open quantity negative b equal to 2. So b now will be equal to negative 1. And a is actually plus 1 by using this one. So we now know the value of a to be 1, and we now know the value of b to be negative 1. So if we go back to the assumed particular solution, just substitute the value of a and b, and we are now given the particular solution. So this is now, particular solution now will be equal to, a is actually 1 times cosine of x, plus the value of b is actually negative 1, plus open quantity negative 1. I'm following this, times sine of x. Therefore, the particular solution now will be cosine of x minus sine of x. This is plus minus, this will become minus. Okay, so y particular will be cosine of x minus sine of x. And to compute for the general solution, The general solution is always the sum of the complementary plus particular. And since we now know the complementary and we now know the particular, just take the sum, and that is our total general solution. So the total general solution now will be y equal to q1 plus q2x plus q3 e to the x plus the particular solution, which is cosine x minus sin of x, which is x. Oh, that is our final answer on the general solution. Oh, that's it, guys. As simple as that one. Okay. For this afternoon, I will not show you the check and the validity of our answer. You now know the procedure, okay? Just take the third derivative or the first derivative, the total answer. Take again the second derivative, then take the third derivative. And to check the validity, go back to the original differential equation. You substitute the computed value of y triple prime. You subtract the value of the second derivative. Okay? You take the sum. And what will come out should be a twice cosine of x. If it is twice cosine of x, after adding this one, okay, the meaning of that is that our total general solution is correct. Okay, so for those students or persons or friends of ours who like my video, please click like, and if you want to subscribe, you will get something from it. Okay, please click subscribe, and if you want to share it to your friends or online, please click share. Good afternoon, Los Angeles.